Okay, good evening, everyone. Welcome back to RoboCup at Home Education Online Classroom. So today we have the third class for Standard Platform Pepper. Okay, so welcome back, and I'm glad to see you. So today we will discuss about Pepper visual perception. So I'm Jeffrey from at Home Education, and today very happy that SoftBank Robotics is with me as well. So we have Austin today to show you the demonstration and also the operation, okay, for the development of Pepper robot. And today we will focus on the vision system to show you how we can use the camera on Pepper to develop some interesting application. Okay, so first, about the logistic. So I'm not sure if anyone joined this class for the first time, right? If you are, so welcome to this class. So we have this class for every Tuesday, 7:30 p.m. for GMT 8 time zone. So we will have the same class for this during this hour for the coming another 2 weeks. So total we have 5 classes, and you can find the detail regarding the time and also the arrangement, for example, like what kind of topic for each class from the first link. Okay, so I put up 3 links. So the first link is about this online classroom arrangement, and other than this class, we have other class as well for standard for open platform and other languages. So you can check out the link to see the schedule and see if you would like to join other session as well. Okay. And for the meeting link, so I believe you got the meeting link from the email after you register. But if let's say you want to send the link or for your convenience, I put up the QR code, so you can just snapshot this QR code and pass it to your friend and colleague. And we will use the same meeting link for all the classes. Okay, so you just need to remember one link, and as long as you come at the right time, yeah, you will be able to access to the class. Okay, then regarding the materials, so the materials that you see in front of you, okay, so the slides, and also we record all the class session and then we will publish together with the course materials. You can find at our course material site. So over there on the second link. So if you are first time and you haven't signed up, yeah, feel free to create an account and enroll to the class, and you can find the materials. Okay, so just in case that you miss out any classes or you want to join other classes and you want to see what we have done in the class, you can check out the video from the online class from the course materials website. Okay, and lastly, also, if you have anything you want to discuss, we will always have Q&A session during the interval, during the break, and also at the end of each class, we have Q&A so that you can interact with us. But if anything that you want to discuss other than the class time, you can go to our classroom and post in the forum for the discussion. Okay, so before I begin the class today, just a final reminder that please keep your microphone and webcam turned off for your privacy concern. But during the Q&A time, it's welcome you to turn on your microphone and discuss with us, right? And also, this class is open for everyone, but just in case that for the Thai community that you might want to ask question in Thai, yeah, don't worry, you can just come forward and ask in Thai, because like we have our local committee from Thailand as well today together with us. Okay, so just relax and get ready for the class. So this is we target to have a more interactive and also hands-on class for this setting. So just in case that you have Pepper with you, we also hope that you have your Choreograph, your development system installed and ready so that you can work together, right? throughout this whole 2 hours. Okay. Also, just in case that you might not aware, the example that we show in this session and also for the whole 5 session, you can actually download from our GitHub link. Okay, so for more information about how to set up your Choreograph and also how to get the sample code from us, RoboCup at Home Education repository, you can go to the first class and materials. The information is over there. Okay, so just in case that you want to know how to set up, you can look at the video and so on. Right, so the previous video already up. You just need to head to the course material site, robotforall.net, to access the material. Okay, so that's all for the arrangement today, and I would like to start soon, but I would like to invite our local committee member just in brief to explain what I have just said in brief in Thai, so that our Thai community can understand as well the arrangement for the class.
Hi Jeffrey ครับก็สำหรับท่านที่เพิ่งได้เข้ามานะครับในคลาสนี้เป็นครั้งแรกเนาะอันนี้เป็นคลาสที่3แล้วนะครับสำหรับคลาสที่เป็น Standard Platform Paper เนาะโดยที่ถ้าหากท่านใดเพิ่งมาครั้งแรกจะมีคลาสนี้อีกนะครับในอาทิตย์หน้าเนาะในวันอังคารหน้านะครับเวลาตามประเทศเราก็คือ 18:30 ถึง 20:30 นะครับถ้าต้องการcourse material หรือว่าวิดีโออะไรเนี่ยก็สามารถที่จะจอยลิงก์ที่อยู่ข้างหลังคำว่า course material ก็ได้นะครับหรือว่าถ้าหากท่านใดอยาก discuss เนี่ยก็สามารถกดเข้าไปใน class group ด้านล่างนะครับแล้วก็ไป discuss ในฟอรัมได้นะครับแล้วก็การเรียนอันนี้เนี่ยจะใช้ลิงก์เดียวเสมอนะครับก็เป็นลิงก์ที่เป็น QR code อยู่ด้านบนนะครับแล้วก็วันนี้เนี่ยจะเป็นในส่วนของการมองเห็นของ paper นะก็คือเป็นเซนเซอร์ที่เป็นกล้องอะไรประมาณนี้นะครับก็แล้วก็ขอให้ปิดไมค์ปิดกล้องนะครับเพื่อprivacy ของท่านเองนะเพราะว่าวิดีโอนี้จะถูกเผยแพร่ในโลกออนไลน์โอเค Jeffrey.
All right, thank you. Okay, let's start the class. Okay, so for visual perception, we divided into this 4 parts. Okay, so you can find like 4 sessions for today, and then you can also find 4 examples in the example source code. Right, so we will take one by one and we will explain, and also Austin will show you the actual operation in Choreograph. Okay, so the first thing we will show you is the most fundamental function that that everyone will use it. Okay, so it's to take a picture. So as we know that Pepper is equipped with various camera, especially on the head. You have a nice camera that can capture the surrounding, so we can actually save this picture for our reference and also for some other analysis later on. And also this take picture function can also be used for various interesting applications. For example, like you can let Pepper to take a photo of your guests. If let's say you design the Pepper as, for example, like an interactive robot during a party, or interactive robot at the counter and so on. So you can use this take picture function for many interesting applications. Okay, and it is very simple. So later on you will see like how we can actually take the photo easily with just one box. Okay, then after that we have face detection. So face detection I think is very common, and also a lot of people would like to have this functionality. And it is very easy to be implemented in Pepper because like the software that comes together or run inside Pepper already have all the algorithm in place nicely, that you just need one box in order to call the function and you can have the result. Okay, so the face detection is already like trained and they have optimized model. So you just need to use it and you can detect faces. Any faces that appear in front of Pepper, you can get the result. Okay, and later on we will see how accurate and also how stable is this features, and also we will see how you can use these features to develop your application. Okay, right. So this face detection is universal, which means you no need to do any training because it is already like trained and also have a model inside there that it will detect any faces. Okay, so face detection is it will detect any faces without need any training take place before the operation. Okay, but also sometimes we might want Pepper to recognize certain person. Okay, for example, like you have you're building one application for hotel reception counter, for example. Then you would like to the Pepper to be able to recognize the guests. Okay, whoever that already check in the hotel, then we already know the particular. For example, we know the name, we know the room number. Then you might want to let Pepper to recognize this person that associate to this name and also this room, so that Pepper can serve better. Because like Pepper will differentiate whether it's this the hotel guest or some guests who not yet sign up for the, okay, so this is not the hotel guest, all right? So which mean for different person, you might have different interaction, for example, like the service that you provide. So this face recognition is important to let people able to recognize certain known person, okay, known person. But that involves some learning, which means you need to teach or you need to let Pepper learn who is this person. And you need to give the name. For example, like this face belongs to this person, right? So you need to associate this. So if you want to do this application, yes, we also have the tools to help you. So in the third part of today's class, we will talk about not just detect any faces, but you can actually train so that Pepper can recognize certain or a particular face and you can associate with a name. Okay, so for example, this person is Jeffrey, this person is Austin, and so on. Then later on, we will show you how the learning phase, which means you need to make some learning training phase. Then after that, we use the learn database, and we will show you how the recognition is done. Okay, so with that, you will have a Pepper that able to recognize certain learn or certain known person. And this can be added into many of your application that require this kind of functionality. Okay, so this will be very useful if you want a more in-depth interaction between Pepper and also your guest or your user. Right. Then lastly, not only to detect the face or to recognize certain person, but also Pepper able to estimate some features based on the facial features. Okay, so for example, it can differentiate, for example, the gender, right? It can also estimate whether is this person is elderly or is a teenager by guessing the age, right? And also Pepper being an emotional, I mean, it can interact emotionally with humans. So one of the very unique features that come together with the software is like it can detect the emotion of the person based on the facial features. So with that, you can actually make the interaction more interesting. For example, like if Pepper actually interact with someone which is who are not very happy, then maybe you can let Pepper to cheer that person up and so on. So many things that you can think of, many interesting applications that you can think of. So we will have this introduced in the fourth part of today, right? So today we will talk about this four main function, and then we can discuss like how you can use this functionality in your application development. Okay, and I think these tools will be very handy for you to design a very interactive robots. Okay, so let's start with the first part. So the first part is to take a photo, take a picture, right? Take picture, I think is very simple. And then we actually have one dedicated instruction box to take picture, right? So you can actually like type in the instruction instruction box library, and then you can find this take picture instruction box. Okay, so this take picture instruction box, it will take picture according to the selected camera and store as we need to store the picture somewhere. So it is stored in somehow home directory of the system, and then I'm recording and camera this path. So later on, Austin may show you like how to find this to extract the JPEG. And in fact, you can actually show this photo using the front tablet in front of Pepper, so that you can also let the user to check the photo taken. Okay, so this will be very interesting, and also it need to be done real time, so that after you have taken the photo, you show the photo in front of the tablet, and then the user can actually check on the photo. And also you can do other things. For example, like you can further develop like sending the photo to the phone or by email or anything. So there are many things that you can do with that particular photo that you have taken for your guests, right? So this one, later we will see how to use it. And you can see the input and output is very straightforward. It's just on start and then on stop. Okay, so you just take, and then after that you move to the next function. Right. And if you open up the example from our repository, you can find this thing. Okay, and you can realize that this is a compile or a combination box, because like it is different from this one. So you can open it up. Okay, you can open it up and see what is inside. Right. So if you open up later on, you will see something like this. Right. You'll see something like this. Which is you have the take pictures instruction box, and then you have the show image. Okay, so the show image is something that I just to display the image on the tablet. Okay, on the tablet, and we need some delay over here, right? And you can see we actually put 2 delay. And what is this delay for? Basically, is to show the image and also to determine how long to show the image. Okay, so it might be a bit confusing, but later on we will explain when we discuss about the when we explain about the operation. Okay, by Austin. Okay, then before you start everything, because this one you need to get the camera feed from Pepper, so it has to be done with the real robot, right? And there is a tool in Choreograph that you can actually real time see the camera feed, right? So when you open up your Choreograph, after you connect to your robot, then you can actually use this video monitor to see the camera feed from the robot. Okay, in real time, which means it will actually send from Pepper through the network to your Choreograph and then to show. But this display is a bit low resolution, so it is maybe not so high resolution as compared to the photo taken. But it is just for you to preview what the Pepper has currently in the frame of Pepper camera. So this is important. For example, like later on when you want to do face detection, face recognition, and so on, you need to make sure the person is inside the frame. Okay, so this will be useful because we are talking about 3D space, and then Pepper is taking photo of someone in front. So you need to adjust, for example, the distance, the height, and so on, because like depends on the height of the person, whether it's an adult, whether it's a teenager. So the height will be different, and also the distance, whether that is the person standing too near or too far. So you can actually use this video display to adjust, okay, or to adjust so that you have some idea how to design the Pepper to stand in front of the person, so that the photo that's taken, you can make sure that you have the person in the frame, right? Sometimes, for example, if the person is standing too near, then you might not able to get the whole body or so on, right? So you can use this video display to preview the camera feed, and also to adjust so that when you take the photo or take the pictures, you have very nice frame that have everything you want within the frame. Okay, so this is something, tips for your development. Right, so if you run the code, the Pepper robot will use the head camera. So Pepper have several cameras, so it will use the head camera to take a picture and display it on the tablet, on its chest, all right, in front of Pepper. Okay, so as easy as that. So I would like to invite Austin to explain further the actual operation in Choreograph. Okay, Austin.
Okay, thank you, Jeffrey.
Right. Okay. So
I'm gonna share my screen.
Yep.
Yeah. Hello, everyone. Just happy to be here. And today we just covered the vision parts from Pepper. And as like what I have before, I guess you have all the projects from the audio movements and vision and other projects. But so here I'm just introduce just followed by Jeffrey. We have the kind of take picture, the facial detection and facial recognition, some functions like that. So the first one I want to give you simple examples like take picture. And I think this function is widely used in any application. Once you want to use the, like face recognition and just use some algorithm by Python, and they only need the picture to give the analysis or do some algorithm to test. Okay, and we're back to the main panel of the Choreograph. It's as URL. I just open in the first one. Okay, don't save. I just pick the projects like Vision, and we have the take picture one, and we choose a PML file. Open it. As the same with Jeffrey's slides, we only see it's a combination box. Okay, I just convinced that you just after this class you need to follow our course to drag some structure box and to make a small program to try on it on the simulator. And then and if you put it into a lot of practice, you better know how to handle this structured box. Okay, like what I told you before, how to convert a box to a lot of box to a combination box. This is what the combination box looks like. Okay, when we click into it, we see the actually logic and the box we use behind it. Okay, I just squeeze a little bit, just like you guys see the more details. This all the program is pretty simple. We just use the take picture instruction box. Let me think about it. Take picture. Okay, when we search the keyword take, there are some keywords just pop it up. One of that's from different folders. Like they all have the animations in it. Animation in it. We can see there have to take picture for now and another take picture instruction box or for Pepper, but they are just act like try to animation. It's not the real vision part. So if you want to know use the take picture, just remember this icon, and they just belong to the sensor folder. And we'll click the take picture instruction box. We can see the inspector. They give us this more details in description. Just a take picture, and with the one of the camera and store it in memory. just remember this is stored in the memory in the recordings camera. The image format is JPG. So what is memory? So we can think our projects. I think we can think of what's kind of connection between the tablets and the Pepper's head. Basically, they're based on BS structure. So we have the browser. We just wanted to search something from the server. So the server side is located in the Pepper's head. Okay. If you mention survey, I guess you currently I use MacBook, and we know the Pepper's head is based on the. Come on. It's based on Linux operating system. So if you want to search, if you take picture and that picture is saved in the memory, but it still is saved in the specific folder. So like this, it said just save the picture in this path. It seems like once you just use the SSH. But I didn't have the real Pepper around me. But once you got the real Pepper, you can enter into the Pepper's head with the accounts and plus with the IP address. Once you got into the Pepper's head, you know what its path looks like. But in my computer, I know the current folder we like is the users asking. This is a basic. It's a base of this path. So if you enter into the Pepper's head, you just find the files from this folder. You can see it. Okay, that's a basic logic or instruction about this this box, and we can drag into our the real panel. Give the comparison. We see that this one they actually added another outputs. It's because the standard one don't have this kind of output, but we added for special uses. Okay. But if they added these outputs, we know that they must change some code. But what that code is about? We can check by double click on this structure box, take picture, and as we know, all the structures, all the basic structures by the Python standards class, they just have the init and unload, and even have the uninput functions defined. I need you to get details about how to if you know how to program this function by Python. After this, you can dive into from our main website. At this part, I just let you know why we use where we added the functions like the outputs here. We only need to get the parameter and give some timestamp and as our the picture's name. That's the reason we need to give the outputs, right? Okay, and finally they just evoke this time function, and they just transfer a time string outside. Okay, as we know, this outputs, the type of outputs is a string. Okay, once we know the details about the take picture, we need to know the whole logic about it. We just follow from the start points, and when the program is running, we can see they're just trying to activate this box, this take picture instruction box, and if the box a success and they're gonna take a picture, and they're gonna stop, and the first one just go to another box. They call it delay. They're trying to see something. We need to delay 1 second, and another one is just transfer to the show image. Okay, if you don't know about what is image function is, I guess you can check from the standard box and show image, and also give the comparison. It's the same. It's the same logic behind it. And you know, this instruction box only for display image on the screen. That's basic function about it. And also they put another extra inputs to accept the string transfer from the take to picture box. Okay, we can I think we know the meanings from the description. This is the on start function means we activate this box, and when we stop it, we're gonna stop it. This is show box, and another one we call the unhided image, means we just need to hide it, right? Hide it, the previous resource, previous picture, or the previous resource. And another one's called input time, because they just transfer the string to accept at the time the time when we take picture. And that's last one on the preload image. This give the time to load a very big image, but this time we didn't use it, by the way. Okay, and okay, when we just take a picture, they just out 3 lines out of here. One is for delay, another is just trying to hide the image, just hide image behind the tablets, and another one just give the time string stamp, just in order to save the image on the specific path, let you know where you can get this image. And when we delay 1 second and we're trying to active the show image, they're gonna show the picture on the tablets. It's very simple, right? So you just take notes about it. Notice about it. When we run this project, we can see we delay 1 second, then we can see the picture really display on the tablets. Okay, and another is the lines trying to another delay, because when it showed the picture and for 1 second, then they just finish all the projects. It's very easy. So which means between this delay, we have the 1 second to show the picture on tablet. So it's very short. When we run this program, you just need to give a notice on it. Okay, so the logic behind this project is very simple. But at this time, I don't have the real robots. But I will let you see when we run this program. You got the wrong errors for some bugs, because those bugs are relied on the real bugs, because you must have the real sensor, and they can use it, and also you can see which boxes depends on real pepper. But beside that, I can show the videos. I just I had it before, and let's see what kind of results we have. Okay, here we go. Just to take a look at this video. I just running this program, and you may focus on the tablets. They're gonna show the picture, but only for 1 second.
注意这个屏幕。
Okay.
OK， 闪了一下。
Okay. As you can see, that's the real consequences after we run this program. They're gonna show a picture on the tablets, and after 1 second, they're gonna display because our project's gonna finish. So that's the simple projects you can try and after this class. Okay. Thank you very much. I'm gonna back to Jeffrey. Continue.
Okay, so thank you, Austin. So let's proceed with the next part. Okay, so as you can see, the tick picture is relatively straightforward and simple. And even in the example, you can find the later part that we can actually display the picture in front of the tablet, right? Okay, so it is quite complete, I would say. So you can straight away take this example and plug it into your application, or you can straight away use this example to start building your application. For example, like after it display what you want to do with the photo. For example, you want to send a photo by email, or you want to do other things. And also you can add some if you remember the class last week, so you can actually add some interaction, speech interaction together with the take photo. For example, you can do, for example, like a speech command for the take photo. For example, you can design one conversation. For example, like, Pepper, can you take a photo of us or me? Then Pepper will say yes. Then after that, Pepper can trigger the take picture box, like what we have done last week, that we can trigger the dancing, if you still remember the disco box, right? So the same example you can actually combine with the example that we just introduced just now, to make the take photo become interactive, right? So it become part of your program, that you can ask the robot to, like, okay, can you please take photo of us? Then photo will say, okay, please stand in front of me about 1 meter, then smile 1, 2, 3, and take photo. Yeah. So that is something that you can straight away develop. I think with whatever example that we already have here, you can easily put them together, and it should work. It should be a very nice, I think, application that you can start building. Okay, right. So and this, I think, is a very interesting if you can include into one of your development for the competition later. Okay, right. So apart from the tech picture, so now we want to do something more advanced. Okay, so not just save the camera feed, but also we want to ask Pepper to do some recognition, or to say some processing of that camera data in order to extract further information. For example, over here, from the camera feed, we want to determine whether is there anyone come across or stand in front of Pepper. Okay, as long as anyone that come into the camera frame, then if you run the face detection program, then you will get the result. Okay, then once you get the result, what you want to do, okay, so you can do another application. But first, let's look at the example. Okay, so for the face detection, again, it's very simple. You just need to call the face detection instruction box. Okay, so we have a dedicated instruction box for face detection. Okay, so you just need to pull this instruction box from the library inside Choreograph, and after that, please check the input output, because like got one interesting output from this instruction box. So as you can see, the input are very normal on start and on stop. So this one is quite common for compared to other instruction box. But if you look at the right hand side, the output, it actually have two new output that you might need to look at it, okay, when you start your development. Okay, so the first one is on stop. Okay, so that one is normal. After you finish the face detection, you can straight away stop the whole application, or you can continue with other things. But the output from the face detection, the other two is number of faces and also on no faces. Okay, because we understand that when we run this face detection, we actually have no idea whether it's someone is standing in front. Okay, so you want this thing to run and detect faces. So which means you want it to run continuously, and then when detect some faces, then you do something, right? So, but the thing is, like, if for the time that nobody is standing in front of Pepper, so what the output's supposed to be, right? So over here, you got a on no face, which means one of the output will tell you, like, if nobody actually standing in front of Pepper, or Pepper cannot detect any face in front, then it will give you a signal. Okay, it will tell you that it didn't detect anything. Then you can proceed with, or you can continue looking, or you can continue finding, and then until you found something, right? Until the robot able to get any faces from the environment. And then our face detection algorithm also, you want Pepper to be able to detect multiple, not just one, but you can have like a group of people, and then all of them are facing Pepper. Then you want to know how many, right? You want to know how many people are actually standing in front of Pepper. So with that, we can actually get the number by number of faces. Okay, so that will tell you the number of faces that appear in front of Pepper. Okay, so these two output seems to be very useful. So let's look further how to use this. Okay, so when you open up the example under Vision folder, then you got the face detection. You open up again, you can find a compound instruction box, or a combination instruction box, and then you just look at the symbol, then you know, right? So you need to further open it, and you can find one face detection box, which is, I think this one is the original one, and it is connected to a custom Python script. Okay, custom Python script. I can't really see the, okay, say number of, right? So it is a custom Python script that it try to tell, or it try to make the speech to say out the number of people. Okay, the number of people. But you can actually use the box that you already learned in the first class, in the second class. The say, if you still remember last week class, the say, you can use that as well. But you need to know how to connect it and make sure that you have the correct data format. Okay, later I think like Austin will explain to you this custom Python script, that what is the input and output. Okay, right. Then you can, another things that you can see in this example is like we have a loop. Actually, you can see a loop that it go to the, from the face detection, it go to the custom Python script, and then it go back to the input of the face detection. Okay, so this loop is when we want to make Pepper to listen, or to say, to observe the environment, to search until it see a person, then you do something, right? So you need the loop to make it continuously searching the environment. Right, for more explanation, I'll leave it for Austin to explain to you. When you run the example, the Pepper will start to detect the number of people in front of it and output the number of detected person by voice. So if, for example, it saw one person, then it will say, okay, I saw one person or something, right? Then if, let's say, like 2 person, then it will say 2 person, and so on. So it will say this out. But of course, you can change the custom Python script to something else. For example, if you see someone, then what you should say, or you see 2 person, then what you should say, and so on, right? So you can modify from there. You can replace with the standard, for example, the say box, and do something else, right? And also, when Pepper cannot find someone, or Pepper cannot see anyone, you might want Pepper to do something as well, right? And you can connect this with your speech interaction program in order for interactive. For example, like when you build a retail robot or something like a robot at the reception counter, then when nobody actually passed by, then you want Pepper, for example, like welcome, please come in, or things like that. Then when Pepper saw someone, then Pepper may say like good morning or good day, what can I help you, and so on. So we can change depend on what happened in the surrounding, or depends on if someone approach or come near to Pepper, then Pepper can change what it need to be said. It need to say, right? Okay, so let's look at the example. And once again, I would like to invite Austin.
Yeah.
Okay.
All right. I'm gonna share my screen here.
Okay.
Back here. Okay. Before we dive into the next function for the face detection, I guess I should let you know the picture taken is a very important function. It's out of the following class for the vision parts. We just based on the pictures, and also like I'm going to introduce this face detection. Okay, we'll just open this project. We know that if you want to detect the person's how many person in front of Pepper, you should also get the picture. But what was it based on? It's still based on the how many pictures you got taken from the Pepper. But we really don't know how the interval time between the picture, how many pictures we follow, and behind it, we know that all the pictures can be taken is based on frame. And in our camera, we have basically the minimum 20 frames in 20 frames in 1 second. So here, I'm going to introduce another important introduction box. It's like a face detection. Okay, face detection. First of all, we should know once we get the kind of face introduction box, we need to know what's the definition. Also, what's this functions used for, and from the inspector panels, we can see the descriptions. They just detect people face and return the number of the detect faces. So it's a very simple and easy and single solely functions we can use, but sometimes it's embedded in another functions or into our application. But still, just remember that we have the note that this to tell us detect even faces that are not registered in the faces database. What's the meaning? That they just mentioned that a face database. Oh, okay, that means they must have the databases to restore all the faces in the database, but they did not depends on the database. They only depends on the pictures. Okay. Okay. Here, I also want to give another knowledge about the face detection. And like the last slide shared by Jeffrey, we know that we have the video monitor panel. Okay, this part. Oh, once we just use the connection to connect the real Pepper, we're gonna see the real scenes from the cameras camera Pepper, and that's you can see the real environment into it. And according to this note, they just mentioned the face databases, and we could I just match with this is a functions from this panel. You can see here they have to learn and they gotta pose and still gotta import the vision recognition database. Okay, we know that it's all about the vision recognition databases. So maybe we're gonna cover this after the next functions. But here I want to know that they really have this kind of databases is only for the recognition. They just not for the face detection, because for this for face detection we only need one picture or the pictures in sequence to try to catch the face in real time. Okay, as we know, it's very simple logic behind it. We're going to start this project and try to run this combination box, and they're going to finish about it. But I still have a lot of inputs and outputs, but we only use this on start and another is over. That's it. And we still have another functions like number of, but we didn't mention it in this program. Maybe if you want a more application or to into your solutions, you can complete it by yourself. We just double click into the program. We can see that they only use the face detection box and another called the see numbers of people. Okay, we use less of the construct instruction box, but we see a lot of lines around it. I guess okay. I guess the logic behind it is a little bit complicated. So let me introduce and dive into to give you introduction. Okay, first of all, we need to drag the standard box here. Try to comparison about it. You can see the same name, same icon, even the same input outputs. So as we know, we didn't add any codes inside its face detection. We need to know about what's this box function and what's the inputs and outputs. That's enough. Okay. All right. We're just from the inputs of face detection, we know that they have the on start, and which means as you know, we already know that meaning that just actively this face detection that started, right? Another one's got an on stop, which means we can stop the face detection, because the face detection we use the camera, and maybe we just temporarily use the camera. Camera is kind of resource and it's the device, and once we use the camera, another program or another resource can't use this camera because they only have one camera there. Okay, that's the reason why we need to stop and to release the resource, wait for other people to use it. And for the outputs, we can get here, they have the unstopping, which means all the operation inside it just running out, they're gonna stop it. And another one is once we detect the people, detect the pictures, we know that they just count the people inside the picture. Basically, they have a the real basic algorithm for the face detection running inside this box, but it's behind the box. Okay. Another one is about the unknown face, right? Just they just take picture and they really don't have faces inside. That's then they just finish the projects. Okay. First of all, I'm gonna double click on this instruction box. Let's see the codes. Okay. They really don't have the codes, but they have the inside it. They have another box, but I don't want to give details about it. If you guys want to know the detail, while we have another box. Okay, finally we can double click on it. We can see the real box behind it, because you know why they just design like this, because they have a lot of algorithms just covered by the service inside. You can't see from the actual code by Python. All right, the Python just kind of provides the API. You just know the API, just how to call this function, but the real algorithm behind it it's invisible. Okay. Right, let's back to the face detection. Okay, as we know, it's a standard box. We know the logic. When we go back to root level, they just start this. They have one line to start this face detection, and another is for over, then running out. And when we inside this combination box, you can see here it's gonna start. They didn't have this stop, right? We don't have a connection that's trying to stop the face detection. So this line is not important. So we can delete, or you can just drive to pretend we make the box logical. Okay, we start this face detection box. They're gonna start it. Okay, gonna start as a face detection, which means they just take picture, trying to running the algorithm operation behind it, and they give the results based on the three outputs. Okay, the first one, we know that on stop it, when we give the detection, then the operation is done. They're gonna over it, then finish out the projects. And another one we're gonna call, they really have the face inside. They just try to give the number. You can see the yellow color for the outputs. We know that they have the different type between this one, right? Oh, okay. We know that yellow ones, we call this number, a type. So they just give the integer, right? For Java program, we know that the integer, it's we can call this number, trying to tell how many faces in this pictures. Okay, maybe it's 1 or 2. Just try and transfer into this Python script. Okay, let's see that we know that it's a standard box or not. It's a very standard box from the library. We can search from this library with the keywords like Python. Okay, that's a basic Python script. It's the same icon and also same inputs, outputs. It's not same inputs. They just added another one for some reason. So back to the definition was this C numbers box. We call the instruction box. When we double click on it, we can see the actually code behind it. We know, we just follow the basic instruction with the class templates. We know we have the init to init the whole class. They mentioned they have the AR test to speech service they use to trying to let Pepper see something, and they have one of the inputs called the input people's number, and we accept the number from the basic detection, and if it's not first, then return, and then you really have the faces gonna see something like this. I saw the person, how many peoples. Okay, that's the basic Python script we know, and also that's the basic it's a less instruction we use in here. Let's check about the results when we're running this project. Sorry, and here I don't know how the video is running. They only have the small video parts from the corner, and if you just keep close to the screen to see it, how is it going. Okay, once we just run this program, you know it's like this. Okay, we run the project, and my face. Okay, my face is in front of Pepper, and at that time, the paper just take picture of my face, and the Pepper say I saw one person in front of it.
看到了一个人，对吧 ？OK， 那我现在有请我的同事。
Okay, I need my maybe we can try to different to let Pepper know how many more peoples they can detect, and I need my coworker just trying to combine with me to let to try this project.
来帮我去做一下。那我们现在2个人是坐在一起。
I need 2 people.
Thank you very much. 那我们要离得近一点，让他所有的都可以看得到。
We must in all into this camera, and all the people can be seen by Pepper. All right.
OK，
at this time, I'm going to run this project.
再问一下这个同事。
我看到了2个人。
Okay, this is the Pepper said I saw 2 peoples. Okay, and if you have more people in front of Pepper and it's in the same picture, in the whole pictures, the Pepper can detect how many people in this frame. Okay, that's the results when we run this program. Also, the project is simple, and we just remember how we use the face detection and write a little bit of Python script to let Pepper see something. Okay, I'm gonna go back to Jeffrey and we'll go to another functions.
Okay, thanks, Austin. Right, I will take back the display first. Okay, so yeah, although it is very detailed, I mean, like you need to know a lot of details when using, but in fact, it is very simple as you compare to like if you need to write the face detection from scratch, or you need to like use some like OpenCV library and so on. So for Pepper, you just need to drag the box and yes, you're ready to go. And in fact, the output, although it is to tell you how many, okay, but in your application development, not necessarily you need to like limit yourself to like counting the number that you detect. Okay, instead, as long as you can detect someone, for example, like you have detect 1 person, then yeah, it actually gives you the result that someone actually approach or someone actually come in front of Pepper, and then you can start your conversation. Okay, not necessarily like you need to tell the result, but it actually gives you you can use this box and it actually tell you like someone actually approach. Okay, so you can use this in many cases, especially when you want Pepper to look surrounding, and when someone or find someone, for example, like you design for example in a retail shop, then you let Pepper like move around the shops, and then when Pepper meet someone, then Pepper might start to like, for example, give the introduction of certain product or give some news and so on. So you can use this to detect or to find person, right? You just move around, and if you saw someone, then yes, you can start the conversation. So I think this face detection instruction box is very handy, especially when you want to design a robot that try to find someone and start the conversation. Okay, so this is something that you can use. And also by knowing like how many people in front of Pepper, you can actually ask more things. For example, like in a hotel, then like if you saw 2 person, although 1 person say that, okay, I would like to check room, or I would like to check the price, then Pepper might ask like, do you want room for 2 person or 3 person and so on. So yeah, so this actually will give a lot of intelligence if you can integrate the result from the face detection into your conversation. It will give your conversation more intelligent, and also make your user feel like the context or the interaction, the speech is actually not just the speech itself, but Pepper actually able to see what happening in the surrounding. Okay, so just now what I just said is some scenario that how you can use the face detection. And in fact, I feel like you can use in many cases. Okay, so the next thing that we are going to do is like you can go further from what I just said. For example, you detect one person or two person, for example. Then you can use one more to check if you can recognize that person or this person is unknown. In fact, like for face recognition, it always starts with face detection. Okay, so you don't need to like put two programs together, but when you use the face recognition, it will start with face detection, which means it detects the face, then only it start to recognize. Yeah, right. So this is one step further from the face detection. But the thing that when you want to use this face recognition, you need to train Pepper to recognize certain person first. You need to build the database first. Okay, but yeah, don't be afraid because like it won't be very complicated. We actually have one box to show you how to do the learning and another box to show you how to do the recognition. Okay, let's look at the detail. So first we start with this unlearn all face instruction box. Okay, so you need to start, although this is not supposed to be the main one, but you always need to use this to actually erase all the faces that that trained before. Okay, so why we need to use this is because like just in case before you or before this program or this development, someone actually used this before. Okay, so someone actually trained, and then you have the database that is still inside Pepper, then this database may affect your accuracy. Okay, because like you might have some database that make Pepper recognize certain person, which is this person is not what you want to recognize. Okay, so you can use this unlearn all face instruction box, okay, in order to erase, clear the database. Okay, so this is something in the programming that you need to know. Then we have one box which is called learn face. So this learn face instruction box is what I said. You can use this box to make Pepper learn the face. Learn the face means it memorizes, try to remember this face. And when you use this, you need to give a name. Okay, you need to give a name that, okay, the person in front of you is who and who. Then after the learning, Pepper will have in the database the face and associate to the name. All right. And also when you use this, later on you will see the recognition will turn green or the light field, okay, turn red, which means the eye, during your learning, okay, later on, Austin may explain further. When you do the learning, sometimes it might fail, okay, which means the learning is not always like for example, take a photo and then it automatically done. Okay, it's not always like that. So when you do the learning, you are actually need to make that person stand in front of Pepper, and then you run the learn phase. Okay, and if the recognition is successful, I mean like the learning is successful, then it will give you some indication from the LED of the light or the color of the light, and green is successful and also red is unsuccessful. Okay, so you need to make sure that you successfully learn the face, then only we can proceed to the next step. Okay, the next step is face recognition. So for this face recognition, okay, it have the output that's on recognized faces. So which means if it's recognize someone in front based on the learn face, then it will tell you the name. Okay, but of course, if you don't recognize, then it won't give you the name. Then maybe you need to re-recognize, or maybe that person is not in your database, and so on. Okay, so these are all the building blocks, the basic function. So you need to imagine how to actually assemble this and couple with the speech, appropriate speech. For example, in the hotel reception counter, if you want to design Pepper that duty in front of the hotel reception counter, then you might ask the person to let Pepper to recognize. For example, like you can actually do the learn phase part of your program, which means like the learn phase is not always need to be done backstage, but you can make it like Pepper will use this learn phase to actually learn new person during interaction. So for example, like, okay, someone actually come in front of Pepper, for example, a new guest come in front of the reception counter, then Pepper cannot recognize this person. Okay, so there's possibility that this person is a new one. So you'll say, hello, you are not in my database. Are you new here? And do you want to like book a room or so on? And the person say yes. Okay, then you might want to say, you might want to decide the Pepper to say like, okay, first let me recognize or remember your face, and then may you tell, may I know your name, for example. Then the person will tell a name, for example, like Alex or Austin or whatever name. Then you can fit this name and run your learn phase, right? So which means you can try to recognize, make Pepper learn and associate with the name that you just received from the person, right? Then after this, the robot will able to recognize the person. Okay, right. This will sound very interesting, but of course, it has some difficulty or some challenges that you might see in such a scenario that sometimes it might fail. For example, the recognition fail or the name is not listened correctly and so on. So how to actually design the work around so that Pepper will eventually learn the face and also get the correct name. Okay, so you need to think of several steps in order to get this thing done. But if you can do this kind of application, then your Pepper will be very powerful, right? It is actually very similar, like someone in front of the hotel counter try to check in a new guest, right? Okay. So learn face and face recognition, this toolbox, later Austin will show you how to use this for face recognition. Okay, so if you open up the example, you can see like now we have more boxes. Okay, the first one is the erase all. So this one is to clear the database. Then we have two combination box. One is for the face learning. Another one, we continue with the face recognition. So you can open it up inside. You can see in the face learning, we actually have quite a number of boxes inside there. And over here, we have a say to start, which means yeah, you need to tell the name. Okay, so there's a name. Then the name have to pass to the learn phase in order to save. And then in order to check if the learning is successful or not successful, it actually connect to the LED, right, of the face, of the eyes, so that it can give you the indication whether the learning is successful or not successful. And then based on that result, you will either you relearn or you proceed for the recognition. Right. So if you open up the face recognition box, you can see inside there, again, you have a speech command, say to recognize, then your face recognition, and then your say name. Okay, the say name means if somehow it's able to recognize, then the face recognition will return you the name, right? Then you will make Pepper to read it out, say the name. Yeah. Right. So if you run the example, the actual effect is like Pepper robot will say start to recognize human face. So it will self-declare start to recognize human face. But of course, in a real application, you can design a different way of dialogue. For example, like, please stand in front of me. I will start to recognize you. I'll start to remember your face, things like that. So you can design to make Pepper tell this thing in a very natural way to the person in front or to the guest, right? Then upon successful learning, then Pepper will say success, or okay, I have remember your face, right? Things like that. Or failure will say, okay, I can't really see clearly. Can you please like stand closer, or yeah, just give me another chance to remember your face, and so on. So you can design this kind of dialogue. Then Pepper will start to recognize, to do the face recognition, and based on the face just learn, and then Pepper will tell the name, whether it's this person Austin or if this person Jeffrey, and so on, right? Okay, so that is the explanation on this part, and also the example, right? The example that we provide to you from our GitHub. So now the next thing is I would like to invite Austin to explain further okay, from the Choreograph side. Okay, so Austin, I pass back to you.
Okay, thank you very much.
Yep.
Okay, we're gonna quick dive into jump into this project because currently it's a little complicated than the other tools because before that we have the take pictures and face detection. I think they have the single logic behind it, but single function behind it, because they only have one algorithm to try to analyze the picture or even get the data from the picture and to save the other place. So we call it this kind of single function box. But this project is a little complicated because this involves the face recognition. Just a comparison with the face detection, that face recognition, as mentioned before, they need to have the face database to store it all the face future. Once the people just come into Pepper, they're gonna search based on they're gonna search all the databases feature based on the pictures you have. That's the logic behind the face recognition. But for face detection, they only have the single algorithm. So that's what's different. Okay, about let me just clarify the process of how to do the learning phases. The first of all, we need to learn the face. I can use this video monitor here because that's the logic when we use the face recognition. As you know, they have some buttons around here. We can know they have the pause, means the sort of stop function. And the first step they need to do they need to store some data into the databases in case we have some data to search out. So the first step, we need to learn something, and which means we need to import some data into the databases and another one was called the import and also export. You can learn and also you can import all the databases from the outside. Try to fill all the databases. Okay. And also you can try the databases, right? And another we call it the standard current vision recognition databases, robots. That means we once we just have this databases, we can send any robots they have. But those databases is stored in the Pepper's head, and if you use the face recognition function, they just definitely gonna match this databases used to. Okay, we just know the slow. We need the databases and need to learn faces. Just put that into the databases, and then gonna search on the databases, and that's the 3 step we need to know. Okay, let's back to this this projects and basic on the 3 step I just told you before. Okay, the first step we know that we need the databases. Okay, here we have to unlearn all the faces. Why is that? But we don't have the need to do it. But for this demo reason, we need to clear all the resources because we don't want to have this kind of same name or same features stored in the same databases. We just need the database clear and clean and make us know how this logic running behind this face recognition. Okay, and all this instruction box we use here, it's a kind of standard box. We can search from the library like unlearn. Okay, and learn all all faces, it's under the sensing folder and belongs to the human detection. They even have the unlearned faces, and they still have this unlearned face. But what's different about that? I don't want to go detail it. You can search about it. And unlearn, and in the simple term, we can know that we just clean all the faces from the databases, and another one is only one faces. Okay, we'll just give a comparison. The first one, we'll drag here. You just compare with the name and icon, even input outputs. It's the same. So we definitely know that we use the standard instruction box. So don't care about that. And another one we call the unlearned faces. When we drag them here, we can see that okay, they can even try compare with the unlearned all faces. They just try to input different types from this from all the inputs. This is change. They have different colors, right? This one was only don't accept all the parameter from the outside, and this one only accept the screen because blue a blue color, the standards for the string type. So once you have a specific name wanted to delete from the databases, you can transfer one string inside it. Okay. I'm gonna just try to. If you don't know anything, you can input it. I'm gonna cover this after introduction face learning. Okay, that's the first step. We know that we use to unlearn all the faces because our database is empty, and at that time, the second step, we need to let Pepper to face learning, like the way we use this button. Like if you connect to the real Pepper, you just click this button, and the Pepper gonna see you and to try to record the faces, and it tracks the features or fixes and store it in the databases. There's a standard algorithm for the face recognition. You can learn it from the website or other documentation. Okay, the second step for face learning. It's a combination box, right? So this is not actually box from the standard box. Then we're gonna try to enter in this box. Oh, you can see there is a very little bit complicated. So we need to make it sense. We can drag it to zoom it out. Okay, back to the root level. They have two inputs. Another one is learn face unlearn, but they didn't any lines try to connect to the face recognition. Another one we're gonna try to connect this one. Okay, here we know it, but this is not useful here. But they still have some logic behind it. You can try to on success and try to connect this inputs. Okay, back here. I just give a quick introduction about the inputs and outputs of unlearn offices. We know that we can active this instruction box for cleared database, and another for the outputs they still on failure and on success. This still, but we don't have any issues to handle on this on failure issue. Maybe we can try to connect other boxes, like see, oh, I just so failed to clear all the boxes, or we can finish all the projects. You know, because we already failed on the first step, we don't need to run this program completely. And this, for some reasons, probably the databases it didn't exist, and also the database is broken. For some reason, the server is down. They always just generate this on failure to the outputs. Once you got the failure, you know where you can get this log. You can see from view and log viewer, they're gonna mention that you have some fails for reasons. You just read the reasons and try to know what happened in the real paper. Okay, back to the face learning. I'll double clicking into it, and we didn't think about this logic. We just entered into this from the start. Here, the first one we use C to start. Okay, that's the introduction before the class, before the previous class. We know that is only C something. Here we can see there's a learning phase now. Just tell people, oh, I'm trying to learn your face, and they just started and running out and connect to the it's a text edit. We know the text edit is trying to give a string outputs. You can type anything you want to make a string, but that's a name. we want to combine with your face, which means when we gotta see that we start to learn your face, and they trying to match this name with your face's feature. Okay, let's back to the unlearn faces. We drag here. They need a string to unclear faces. So you know what, you get the name with the face feature, which means the face when we face in front of the paper, they know I'm Tom, and they're gonna store it on databases. And also you want to delete this or clear the faces on database based on name. You can transfer the database like Tom and connect to the unlearned faces. Then they just delete the specific item in the databases, which is to remove the name with the faces features. Okay. That's the difference between the unlearned offices and another one is the unlearned face, which is delayed. Okay, they're trying to give the name in it and try to connect with this face, learn face. We can find the keywords learn face. Okay, drag here. Okay. The comparison with that, it's really very same. The same input, the same output. So don't care about that. We just know they just writing some algorithm behind it. They just tell people, we're trying to take picture and extract the feature, and maybe we're gonna save it in the databases. And that's the logic behind the algorithm. Okay, what we focus on, it's only for the outputs. They have the on success and on failure, which means if you didn't have face you didn't have face, or you really didn't face on the paper, which means the camera didn't catch your face. That means we learned faces failure. That's the only reason for that. And also on success, they just capture the face from the pictures, and another one for failure. So they can't recognize two faces in the camera. So if you want the solutions, you should run the face detection. Tell that we only have one people in the picture, then try to learn this face instruction box. Okay, and when we successfully learn the faces, and they just try to see something, it's another say instruction box to see that, okay, I learned successfully. And another one just LEDs that's control the light, the LEDs on Pepper's eye. Okay, that's a standard box. We can search from it. Compare with that, it's nothing gonna change. But we can give the parameter on this instruction box. Maybe after class, the next class, we're gonna introduce this kind of instruction box. This belongs to the lights function. Okay, once they used to learn the faces successfully, they're gonna finish out this combination box. They just told the next one, I learned successfully and try to give recognition. Okay, this also is a combination box. Okay, it's very simple. They only have 3 instruction box. The first one is also say blocks. This is trying to say what? Begin to recognize the face, and then try to run the face recognition. Okay, we just try to just comparison. It's the standard instruction box or not. Instruction face recognition. We drag into the panel and give the comparison from the input output. It's the same. I didn't change any of the codes behind it. If I know how this instruction explanation, you can try to double click it on face recognition. You can see, oh, they still have another instruction box inside it. And while we double click it inside it, okay, we try into deeper levels of this this box. We can see it's actually codes behind it. If you got interested in, you can learn based on the website we provide to you, and also you can dive into the code, the real code, read it. It's I think it's very simple. Okay, we're back to the previous level, and here they have the inputs and outputs. Further on start, they just try to active this face recognition, and then the one we call it on stop, which means I'm gonna stop this recognition. I like what I told you before, because it's fixed recognition, they need the cameras on, because camera is a limited resource. We need to use it after done with those cameras. We need to release all the resources to with other people use it. Okay, after running this face recognition, they have 2 outputs. One of that's unstopped, another one is called unrecognized face. Okay, that's the ends of this algorithm. I believe this is algorithm running behind this box, right? So they try to search based on the picture they have, and search from the databases and try to match which pictures belong to Tom, and find the Tom name and give the outputs to see that the Tom's name. Okay, they just use the C test. You can see here this. Okay, they just accept the name. Before that I just transferred into Tom's name with the match with my face, and at this time they just give my names out and say it out. Okay, then finish out the project. Okay, let me give you a summary about the face recognition. The first one, we always remember the first step, we need to clear the faces. It's not really clear the faces. Also, we need to start or just get the databases okay, started okay, and then we just learn the faces. At this step, all the faces are learning based on the picture of the taken by paper, and also saved into databases. Where this extract the feature into the basis, and in next step, if we want to use the face recognition, I also need to take a picture and extract the feature, and then search on databases. They just have some a comparison, the comparison with the debts, and they have some threshold to control how percentages should be the same person. Okay, then this gives the name on it. So that's a kind of simple, but the algorithm behind it is very important. And also our paper this actually in binding this algorithm is not from the online. Even we run it on offline, it's a very good algorithm inside Pepper. Okay. We know that it's the whole process of this project. I need to show the results after running this project, but I remember that first of all, when I run this project, you need to notice that the first step, I need to stand in the front of Pepper, and they're trying to unclear all the faces, and then the Pepper is trying to capture my faces to learn the face. Digital, I'm starting learning a face, and then the stories on database. Then I still keep my face in front of Pepper. They just gave a face recognition parts, and finally gonna search from the databases to see my name. Okay. Here, okay, I still have a very small video, and just I guess you can see it from zooming out. Okay, I'm gonna start it. Run the program. Okay, let's start it. Okay, just Pepper just saying, I'm starting started to learn a face. Okay, it's very important part that it's very important, but they just trying to recording my faces and give to learn the features of my face. They just said I got successful to learn face. Okay, just learn the face successfully, then go to the face recognition. This is trying to recognize my face by searching the features from databases. Okay, this is recognize my name is Xiaoming, but at this time I think you should focus on. I changed another name. My name is Austin, and they're gonna say my name after learning.
是这样的一个过程。他学习完我呢，把我变成小明啊，这里面我再把我的名字改一下，那我叫 Austin。
Okay.
我把我的
I changed the name.
变成 Austin。
I changed my name. It's not Tom. It's Austin. Successful learning. Okay. This is learn my face and then search from databases, find out, oh, my name is Austin. Yeah, that's a real algorithm running behind its Pepper. It's a very powerful and it's a precise algorithm running in it. You can try, and after this class, it's a very amazing journey if you got a face recognition. Okay, that's basically all for the face recognition. Also, it's a very complete parts for the vision, and yeah, that you must learn it and try it after this class. I'm back to Jeffrey to continue other parts. Thank you very much.
All right, thanks, Austin, and yeah, right. Okay, so let me put up my slide first. Right, so just now, yeah, Austin has used a very detailed explanation on the face recognition, so how to learn and also how to do the recognition. Although it all happened in just a split second. So, but if in real scenario or in real application, usually we might learn beforehand. For example, like you develop some application, for example, a library, Pepper for how to say, as a librarian, for example. Then Pepper will move inside the library and try to entertain the guests, for example, like the user of the library and so on. So you might want to design so that Pepper can recognize, for example, other librarian or other administrator of the library and so on. So it is actually work the same if, let's say, you design a Pepper for a retail shop, for a restaurant and so on. So you want to make Pepper able to recognize the staff, for example, so that Pepper won't go and like introduce the product to the staff, for example. So you try to make Pepper to always serve the customer, which is like the unknown faces and so on. So you can use this. And in fact, just now I also said that you can use the learn in real time. So which means you can ask Pepper to give instruction to the user in order to recognize them. For example, like you ask what is the name, then you use the learn to actually learn the face, then you associate this thing. So everything can be done. And what I just mentioned, this one, I will really love to see if, let's say, you can really incorporate into your application development and submit for our competition. So because this is a very nice human-robot interaction, especially in at home, and you can design this for many applications, whether you can put Pepper in, for example, hospital, home environment, in retail, and so on. So you can really show how the powerful features that we have in Pepper can be used in real life. Okay, so and if you connect this with the speech, okay, so then it becomes very interesting, because like Pepper suddenly it can speak, it can having conversation with the person in front, for example, the new guest, the new person that come into the hotel or come into the room and so on. Then you can do the interaction, and you can use the face recognition to add more functionality or more intelligence into the conversation. And also after that, you can actually do something more based on the facial features. For example, like based on the face, not just able to remember the name, for example, like to recognize and associate with the name, but the software within the Nauchi, which is run on Pepper, can give you some extra information. Okay, and this extra information is something that we are going to discuss in the next part. So this facial features recognition. So which means by just looking at the person in front, Pepper can actually do some estimation. For example, gender estimation, age estimation, and also the emotion, the mood estimation. For example, if the person in front is sad, happy, or just normal, and so on. So this might be very useful, especially when you design, for example, you design Pepper for the home, for folks' home, or for some like orphanage and so on, or in the hospital, where you need or you try to design Pepper to provide some mental care, for example. Then in this kind of application, this emotional detection or emotional estimation features will come very handy. Yeah, so this is the real application for the coming features. Okay, so let's have a look on this facial features recognition. As I said just now, all the function for this facial features recognition in Choreograph, they already like packaged into very handy instruction boxes, right? So for example, the first one is get age. So by the name, I believe you already know this one. It will return the age of the current person, of the person in front. Okay, and this is estimation. Of course, it's not how to say like accurate, but based on our testing, it's quite accurate or accurate enough, and you can use it for some estimation or to help in your conversation, right? And then similarly, you also have the get gender, which is you can identify if the person in front is a lady or man, and then what is the age. For example, it's a teenager, if let's say it's within 20 to 30 or 40 to 50 or below 20 or below 10 and so on. So with the age, you can actually give different services. right? Or you can actually change the conversation based on the result of the age and also of the gender. For example, like the services. For example, when we have a retail robot or retail pepper robot that try to promote certain product, for example, then certain product might be okay. Maybe this product is suitable for the male customer, and certain product may be suitable for female customer. So based on the gender estimation, then you can give more better recommendation, right, or more appropriate recommendation of the product and so on. So these are very how to say, it will make the robot that you develop much more intelligent, right? Okay, then the third box is this get expression, and inside this get expression box, it will return neutral, happy, surprised, angry, or sad. Okay, so these are the emotion that can be estimated based on the facial expression, the facial features of the person in front of Pepper. Okay, so you can use this, especially like just I said, if you develop Pepper for some mental care application in hospital or folks home or orphanage, that you want Pepper to act like the nurse that can actually like look at, for example, what is the current emotion? Is the person like moody, angry, or sad? Then you will try to make the Pepper change a little bit on the tone in order to improve the conversation. So this is a very, very powerful features that I really hope you can design this into your application. Okay, so if you open up the example that's given, you can see is the demonstration of these three boxes, but it is packaged into this combination box that you will need to open up one by one to see what is within it, what is inside there. So I'm going to leave this part for Austin to explain, because we also almost running out of time. Then when you run this program, then yeah, straightforward, Pepper will start to detect the age, not to say detect, actually to estimate the age, the gender, and the mood of the person, and say it out, right? And say it out like, what is your age, what is your gender, and you are angry now or you are happy now, and so on. So it will speak out. Okay, so it's a very simple, straightforward example demo. So I will let Austin to further explain on the Choreograph operation. Austin?
Okay. Thank you, Jeffrey. And the final part is very easy, and also it's not that complicated. And then behind the logic, and we're just running the algorithm. This is a single function running on Pepper, because we need to know the people's age and its gender expression. And in some, as we know, we just dive into the AI field. We know some algorithm running behind it to make the robots like human being. And this the third party, even from the Google and Microsoft, that they just always provide this kind of function to give the expression of from people. And but all of that is based on one picture. They need one picture, the frame, trying to capture your face and to know, just give you some definition. If your mouth or the eye just give a different shape of that, they can see that. Oh, they just give a the definition or threshold to let you know how old are you and how the expression you have. Yeah, it depends on the algorithm. In Pepper, we know that it is already embedded out of this algorithm, and we can try to get the age. Get age. You can see here, and this is standard box. We have some parameters like a confidence threshold, which means we can control it how much we just have the similar comparison with the algorithm allow you to give the results. It's based on the threshold and also give the timeouts. Yeah, normally we just give it a 10 second to recognize it. And another one is called age, get age, also gender, get gender, and get a gender and also get their expressions. And it's very simple. Based on the inspector from the description, you know that they have different emotions like neutral and happy and surprised, angry and sad, and it just that's the results the algorithm can feedback. Okay, back to this project, we know that this is trying to give the age, then give the gender, and then give the expression. Just very step by step to let you know, just give you the prediction or as the give the real functions of the algorithm. Okay, all of that is gonna we call it combination box, and when we click into it, they only use the get age from this standard box. You can drag here comparison with the input outputs. There's no difference behind it. Okay, and you can change the algorithm, and you just accept it when you want to use this instruction box. And they have two outputs, one of them on arrow. They have reasons they can raise some errors because we didn't get a face, and we got a timeout, and the camera has some problem with that. Those reasons can lead to this box failed. Another part is another outputs is gonna stop, and also they have different colors. Is it the colors is trying to see the number? It's about your age, right? So if they got success, it's gonna transfer to a number into the see age. They're gonna say it out. Another one is about the gender detection. It's the same, and they also can be arrow, the same reason with the get age, and also another one for the gender. But gender, they have different types. They can tell you it's a female or male, and trying to say it out. And it's finally the final introduction box. We have the expression impression box here. And it's the same reason for the on arrow, and other ones for the on stop, because they still have the string the parameter out, and they have different types trying to transfer to the C instruction box. And but by this instruction box is different than the other two. We can see the parameter here. They even have the confidential threshold and timeouts. They have another types of expression. Totally, they have the five that you can take a select unselected on it to get according to your business logic to configuration it. Okay. And that's all the projects, and running all this kind of box one by one, and the other box is a single function running the algorithm behind it. Okay, but for this parts, I just want to leave the homework for you to try this algorithm. It's very interesting and amazing when you stand in front of paper. But I still have got a video, but it's not work here. Sorry. I believe you can try this project of this class. Okay. That's basically all for me, and thank you very much.
Right, okay, so thanks, Austin. Okay, so we have come to the end. So let me put up the assignment. And also I will try to conclude what we have learned today. Okay. Okay, right. So screen. Okay, so for the assignment for your exercise, as I said just now, it will be very interesting if you can combine what you have learned last week with the example that you have learned this week. Okay, so over here we try to put them together so that Pepper can, for example, you can make Pepper to learn the person name by asking verbally. Then you record this name and then you use the learn phrase to actually learn the phrase. Then you associate them so that when the human asks, do you know who I am? Then the Pepper will try to recognize. If not recognized, then you start this procedure in order to learn. And also the name of the person can be any of, or you can give a group of name, right? Okay, as the example previously. Then also you can design the take photo and display by using voice command. So as I said just now, like you can make example that, for example, can you take photo of me? Then Pepper will say yes. Okay, please stand in front of me and then take photo. Then you can display the photo. Or Pepper can offer, do you want me to take the photo of you or take the photo of you with your friend and so on? So you can design this into the conversation and combine the example that's given today into the conversation and so on. So with that, you can, with this, if you're able to do this exercise, I believe you already have very good foundation to design your Pepper application or to develop Pepper for certain application in the at-home scenario. Okay, so with that, I've come to the end of the class for today. And based on the time, we have several minutes for Q&A. So I would like to invite our local committee member to summarize what we have done today, and also we will proceed to the Q&A. Okay.
Hi Jeffrey ครับก็สำหรับวันนี้เนาะก็คือเขาสอนนะครับในส่วนของการที่จะใช้ตัวกล้องนะครับที่อยู่บนหัวของเปเปอร์เนี่ยไปทำงานต่างๆเนาะเช่นอันแรกก็จะเป็นในส่วนของการถ่ายภาพนะก็คือสามารถที่จะกดถ่ายภาพได้นะครับแล้วก็เซฟภาพอะไรประมาณนี้นะครับถัดไปก็คือในส่วนของ face detection เนี่ยก็คือเป็นในส่วนที่สามารถที่จะนำภาพเนี่ยที่เรามองเห็นเนี่ยไปทำการค้นหาหน้าต่างๆนะครับว่าแบบมีหน้าอะไรบ้างที่อยู่ในนี้นะครับอยู่ในภาพนี้นะครับแล้วก็อันที่3เนี่ยเป็นในส่วนของ face learning and recognition เนาะก็คือมีการที่เราเนี่ยสามารถที่จะเทรนให้ตัว paper เนี่ยสามารถรู้จักหน้าของเราได้ว่าหน้าที่เข้ามาเนี่ยคนนี้เป็นใครหรือว่าถ้าไม่รู้จักเนี่ยก็สามารถที่จะให้มันเรียนรู้ว่าโอเคหน้าเนี้ยชื่อนี้อะไรประมาณนี้นะครับส่วนในอันที่4เนี่ยก็คือ facial feature recognition นะครับอันนี้ก็อาจจะเป็นการใช้คำว่าอะไรเป็นการหาฟีเจอร์ของหน้าที่อยู่ในรูปนะเช่นเป็นการดูอายุคาดเดาอายุการคาดเดาเพศหรือว่าในส่วนของการคาดเดาอารมณ์ต่างๆนะครับก็สามารถใช้งานได้นะก็จะมีบ็อกซ์ที่เขาดีไซน์มาเขาเทรนอะไรมาเรียบร้อยแล้วนะครับก็สามารถนำไปใช้งานได้นะครับแล้วก็ในส่วนของassignment เนี่ยก็คือเขาพยายามจะให้เราเนี่ยรวมนะครับในสิ่งที่เราเรียนวันนี้แล้วก็จากครั้งที่แล้วที่เราเรียนนะครับก็คือวันนี้เนี่ยเขาก็จะให้เราเนี่ยทดลองนะครับเทรนนะครับตัวหน้าของเราเนี่ยสมมติว่าเรามีเพื่อนหรือมีกลุ่มเพื่อนกัน 3-4 คนเนี่ยก็ลองเทรนหน้าทั้งหมดทุกคนนะครับเข้าไปในส่วนของตัวเปเปอร์แล้วก็ตั้งชื่อทั้งหมดนะครับแล้วก็ให้รวมกับในส่วนของสปีดที่เราทำมาที่เคยเรียนมาในคาบก่อนหน้าก็คือให้ลองถามเมื่อ user ถามเปเปอร์ว่า do you know who I am เปเปอร์จะต้องตอบว่าโอเคคนนี้ชื่ออะไรประมาณนี้ก็คือแบบอธิบายอะไรประมาณนี้ได้ว่าคนนี้ชื่ออะไรหรือว่าสามารถที่จะหยิบ ฟีเจอร์ต่างๆเนี่ยเข้ามารวมกันก็ได้นะครับแล้วก็อีกอันนึงที่เขาให้ทำก็คือให้ถ่ายรูปแล้วก็โชว์รูปด้วยคำสั่งเสียงเช่นบอกว่าเปเปอร์ถ่ายภาพฉันหน่อยมันก็จะถ่ายภาพมานะแต่ว่าตอนนี้เปเปอร์ซัพพอร์ตภาษาอังกฤษเนาะก็พูดเป็นภาษาอังกฤษอะไรประมาณนี้นะครับก็อันนี้เป็น assignment ที่เขาให้มานะครับแล้วก็ตอนนี้ก็เปิดในส่วนของ Q&A แล้วนะครับหากท่านใดมีคำถามอะไรก็สามารถที่จะถามขึ้นมาได้เลยนะครับโอเคเจฟฟรีย์
All right, thank you. So yeah, maybe I can open up a short question if you have any question. So I would like to know like what is do you able to catch up with the class and yeah, you can mention like if you face any difficulty, is the explanation or the delivery of the content clear enough for you to start learning how to develop Pepper? Or you have problem that without the real robot you can't actually do something, but in fact there are many things that you can do even without the robots, especially like for example the speech last week you can do like most of them. The only thing that's missing is the recognition, but of course you can type in and yes you can still check your conversation and so on. So this class will serve as an introduction so that you know what is going on, and also it gives you idea how to design your application. I think this is very important, and I would like to once again that encourage everyone to try to attempt the assignment so that you can develop some of your application, although it's not complete or fully, but yes, please develop some of the application and submit for the qualification, right? So with that you can actually like get a chance to attend our on-site workshops that we actually have real Pepper over there for you to program. Okay, so I would like to know like is there any question from the audience? Yes.
Yes, Dr. Jeffrey.
Yes.
If someone doesn't have the robot with them, how can they test the code?
Okay, so I think if you follow the class, I think like many times, we actually try to explain which part with the robot you can run or which part you definitely need the robot. For example, like in today's class, you need the part that to detect. Of course, like you need to use the robot camera, so you can't really do much thing about this. But what the code actually or what the contents today can help you to understand what kind of development you can do. So you can actually add this part to, for example, like last week, we mentioned a lot about the speech. So for the speech, even though you without the Pepper, you can still do the conversation. You can still design the dialogue. You can still do a lot of things other than the sound recognition, the speech recognition. So even without the speech recognition, you can still use the dialog box to actually input so that you can see the conversation. I think like if you refer to the video last week, you can see, in fact, Austin actually don't have the robot currently because of the situation, the local situation, but we can still able to run part of the code that you can do the conversation. So the class here is to expose to you what Pepper can do. And from there, you try to design and try to test on certain example that you can run even without Pepper. Okay, so I really hope that you can, yeah, try the example that we show you, and some part that not require the robot, you still can see the result from the, for example, the simulation, the virtual Pepper, and also the dialog box. You can see the conversation. So with that, I hope you can still do some development.
All right.
So,
okay.
Okay. Right. So
Thank you.
Yeah. So the purpose of this is because I understand like most of you maybe don't have Pepper, but the purpose of this class is to expose to you so that you know what you can do with Pepper, and then you can develop and try to design your idea and then put some prototype. For example, like you can do the speech partly. Okay, you can add some module from the speech, from the camera and so on to come up with your idea, because we need this fundamental development in order for us to do the codification. Okay, so I really hope like you can go through the videos and also the materials and try from now onwards. You can actually start, because like I think we have introduced a lot of example that you can use this example to start develop your application for the competition. So is that okay? So
Okay.
if is there any other question? You can ask in Thai, okay? So just in case like you will prefer to ask in Thai, yeah, you can ask in Thai. Is there any question? Okay, so never mind. If you don't have question, then I would like to close the session today. So thanks a lot for you to attend today, and I really hope you can start look at the example, look at the content, and start thinking what you want to develop for your team using Pepper. And I hope you can pass the qualification so that you can have the chance to do the on-site workshop. And during that time, you will have the chance to develop your application based on the real Pepper robot. Okay, right. And of course, like whatever the work that you do, even without Pepper, you can still join for the qualification and also the online challenge. Okay, it is totally possible. You can see online challenge 2020 and 2021. There are actually several groups that can do Pepper based purely on simulation. Okay, so you can look at their work, and you can check our YouTube channel for the video and so on. So that will be a good reference for you. So today, thanks a lot for you to join, and I really hope to see you again next week and start discussing some idea with me, with us. And also thanks Austin to be here and give us very detailed explanation as usual. So with that, I would like to close the session today, and I hope to see you next week. Okay, thanks and goodbye.